Hello, everyone, and welcome back to the Cisco Optics Podcast, where we talk about pluggable optics for networks. Multi-modeFiber has been the workhorse for fiber optic communication within a data center for years, as well as a choice for Ethernet backbones in office buildings. It has a rich history that goes all the way back to the first optical fiber standards when 100 megabits per second was a huge data rate. Anybody remember those days? This is episode 54, and we continue our conversation with Hao Dong, Market Technology Development Manager for Corning's optical communications business. We go into more detail about multi-modeFiber and its overall solution-level cost benefits. Hao Dong is a Market Technology Development Manager for Corning's optical communications business. Within this role, he focuses on technology and market trends to identify, evaluate, and develop leading optical network solutions that form the backbone of today's connected world. Hao has over 18 years of industry experience and has held various positions in engineering, development, and marketing within the fields of optical components, fiber lasers, and optical communications. Hao holds a Bachelor of Science in Physics from Wuhan University and a PhD in Physics from the University of Connecticut. And now join me as I talk with Hao Dong. Okay, back to multi-mode. So, what exactly is a mode?
What exactly is a mode? So, usually from the physics standpoint, you can, you can look at the mode, view the mode as a distribution of your power distribution of your optical wave. Right. So essentially, your optical signal is kind of like it's a optomagnetic wave, right? So for any kind of a magnetic wave, so certainly you have to, it's governed by the Maxwell equations and your boundary conditions. By solving those, equations, eventually you will get the different solutions, right? Those solutions mathematically, it's called a mode. From other perspective, if you look at those mode propagating inside the fiber, I think they could be viewed as a different optical groups traveling inside of the fiber by following different paths.
Right, at like different angles of incidence against the core cladding interface.
That's right. Yep.
Like those paths.
Mm-hmm. Right.
So that would be like a ray. The light ray model, right?
Exactly. Yeah.
The ray optics model. I always like to think of like a very simple analogy, like with a rope. If you tie a rope to a doorknob and you start shaking the rope up and down, you'll get, if you do it at the right speed, you'll get a vibrational mode, right? Where if it's just kind of going up and down as a single hump going up and down, that's like a first order mode, right? And if you do it at twice the rate, you'll kind of get like a two hump thing that kind of alternates, right?
That's right. For those modes, I think more specifically, we call them a spatial mode, right? Spatial mode. So from that perspective, you can imagine. I think literally, it's just a very specific power distribution in the spatial dimension. So, like I said, in theory, the propagating optical signal is kind of an electromagnetic wave, right? And therefore, end of the day, it's a power distribution within the fiber, right? And also, it's governed by Maxwell equation and certain boundary condition. And if you really, come to the solution, to these equations, that's basically how we got the special mode. So I think the reason why we care about the special mode is because those different modes behave very differently inside the fiber, especially for the for the multimodal propagation, and they follow different paths at a different speed. When they see the different refractive index, their speed will be different, right? So that's why we care about those modes, especially for multimodal fiber.
So what impact does that have? Like, so why do we care about the fact that these modes travel at different speeds down the fiber?
Yeah, there's in the multimodal fiber, there is a thing called the mode dispersion, right? So the mode dispersion exists because different light with different modes have a different path length, and they travel at a different speed. Therefore, if you imagine when those rays, right, modes entering the fiber at the same time, but afterwards, when they exit the fiber at the other end, they exit the fiber at a different time. So if the pulse goes in, so with this kind of a time difference, the pulse will be spread out. So that's what we call, the mode dispersion, right? So that's a.
So if you send in an optical pulse, like just a burst of energy, a burst of optical energy, it may come in with a certain duration, but by the time it comes out, it's actually much longer duration.
Yes, yeah. When you put those energy, when you put those pulse in a format of a signal, right, 1, 0, and those series signals together, so the pulse dispersion, the pulse, pulse dispersion and mode dispersion could be a serious issue because it's blend those signals together. So certainly, from the fiber design standpoint, you need to take that into consideration and trying to address the issue. So that's a big concern when it comes to the multimodal fiber design as well.
Okay, so so modal dispersion is a big thing, because I guess it's something you think about like every day.
Exactly. Yeah, the modal dispersion is a big thing. So, but I think from fiber design standpoint, we have a well-established way to address it. That's what you mentioned before, the gradient index of fiber, right? So the way how it works is, for the gradient index fiber, basically, for those different modes, as we said, the multi-mode light going into the fiber, right? The interesting thing is for the fundamental mode or lower order mode, they tend to stay in the center of the core, and for the higher order mode, they basically distribute the power distribute kind of like closer to the edge, closer to the cladding, right? So
so they're closer to the cladding. What kind of shapes can these higher order modes take? Like, what would they look like?
They could be it could be symmetric, the rings, or like flowers, but typically they are in the symmetric shape.
Symmetric, like circularly symmetric, or like XY symmetric?
It could be either way. Symmetrically, circularly symmetric, or like I said, like a donut shape. But versus for the fundamental mode, it's a circle, right? It's the power is kind of like more concentrating in the center. So that's a way we like. We want the power to be more concentrated, to be more efficient in terms of carrying the information along the fiber.
What are the main applications of multi-mode fiber?
So for the when it comes to the applications, I think you have to basically look at the key metrics associated with the multimodal fiber, right? So for example, the reach is a very important metric you need to consider when it comes to the network design. For example, if your network is 2 kilometers, you need to kind of like connecting your data center like a 2 kilometers away or 5 kilometers away, you know your multimodal fiber is not be able to deliver the such connection, right? So multimodal fiber is not an option.
Because
so the reach is
the modal dispersion will limit that reach.
Exactly, because of the model dispersion. Yeah, model dispersion in that kind of application, the model dispersion is the number one concern. So naturally, when you consider typically for any distance longer than 5 kilometers, I would say now these days the single mode fiber will be the natural option. So the reach is a very important factor to consider. The other thing is the cost, right? Relatively speaking, the multi-mode solution is a lower cost solution comparing with a single mode, right? So if you're, say if your application is kind of like super sensitive to cost, cost is a higher priority, then we recommend to go with a multi-mode, to consider the multi-mode if the reach is a short distance.
Because of the cost of the fiber itself or the cost of connectivity?
Oh, that's a very good question. So here when we talk about the cost, we should take all things considered together, including the fiber, cabling connectivity, and also the laser source. So we typically say multi-mode is relatively more cost-effective solution versus single mode. The real the fundamental reason is because the laser source, because as you know, multimodal fiber transmission, typically we use the VCSEL, which is very cost effective versus the DFB laser. From a manufacturing standpoint, the VCSEL, we always say the multimodal fiber is designed to match the multimodal. It's designed to match the VCSEL, right? And eventually, as you can tell, the core size of the multimode is way bigger than single mode, right? So when it comes to the alignment, the VCSEL launching into the multimode versus the DAB laser launching into a small core of the single mode, obviously, it's way easier for the multimode to finish the job. So that contributes a lot to the lower cost of the multimodal solution. But that's the laser source part of the story. But when it comes to the fiber, the multimode actually it's not necessarily cheaper than single mode, right? Because the core size is bigger. You need to put more higher quality material in the core. End of the day, the fiber or cable might be more expensive than the single mode. But when it comes to the laser side, to the light source and transceiver, the multi-mode is cheaper.
So overall, end to end, you still come out lower cost going with the multi-mode and the VCSEL based transceivers.
Yes, exactly. So that's you brought up a very interesting part of the discussion. So in early days, we know the multi-mode is very very much more cost effective than single mode, right? If you look at the 40G situation, 100G situation, it's no brainer for people to go with the multi-mode for shorter reach. But when the transceiver speed kind of like migrated to higher speed, like a 400G, especially when the silicon photonics getting more and more mature, people start to questioning the cost effectiveness of the multi-mode, right? For us, one of the work we did is to quantify or quantitatively analyze the installation cost of the multi-mode versus single mode. Of course, in this analysis, you need to take into consideration everything, right? Your transceivers, optical contributions, cabling, connectivity. So long story short, our conclusion is even at a 400G, if your application distance is short, like less than 100 meter, multi-mode is still more cost effective than single mode. So
okay.
Yeah, so because of the lower cost, I think that's that's one of the two most important factors or features of the multimode, so that the multimode is still being widely deployed in data center applications today.
Yeah, and I think at least from my perspective, I mean, Cisco's been in the data center business for literally decades, right? And multimode was always the choice for the data center reaches, which are short reach. There's such a huge install base, and not just, I would say not just physically the install base, but the mindset of people, right? Because I think a lot of people out there, including probably people listening to this, they're not optics and lasers people. They haven't spent their life like you have, working on splicing lasers, working on the designing optical fibers. So they're thinking more about the equipment side. And if they're comfortable with multi-mode fiber, it's just a very nice comfort zone. And so even at 400 gig, if that's available, then yeah, that's what they're going to gravitate toward.
Right. Yeah. So especially like we mentioned before, right? For multimode solution, not only we consider it as a lower cost solution, but also there is a great feature of the lower power consumption.
That was the third part of my conversation with Hao Dong. Next time, we'll get into power consumption considerations. We have a new website. It's optics.podcastpage.io. You can either listen there or use the same podcast platform you've been using all along. Please subscribe. Better yet, leave a review, especially if you've been using Apple Podcast. Remember, we're part of the Cisco Podcast Network, where you can find other great Cisco podcasts too. We also have educational videos on YouTube. Just go to youtube.com and search on Cisco Optics. Thank you for listening. This is Pat Chow, Product Manager at Cisco Optics. The next episode is part 4 of my conversation with Hao Dong. Until next time.